Hello, good morning, everyone. Welcome to Introduction to CREODIAS webinar. Today, with my colleagues, Jan Musiał and Marcin Gil, we would like to present you CREODIAS platform. So this will be a special edition, technical training. So we will focus more on technical side of our CREODIAS platform. Today's agenda for the webinar is a brief introduction to CREODIAS. I will spend a couple of minutes showing you the architecture, what the platform is about, showing you what datasets do we serve on CREODIAS platform, and what kind of virtual environment you can find on CREODIAS. Later on, my colleague will show you a use case on derivation of vegetation indices from Sentinel-2 imagery. And then another colleague will give you tips and tricks based on the most common asked questions by our users. The questions asked to our CREODIAS technical support. And at the end, we would like to ask you to give us a short feedback about our webinar. So the next one we will be prepared. Will be prepared on your answers. Okay, so let's start from the beginning. So let's start from the introduction to CREODIAS platform. CREODIAS is a cloud-based platform serving datasets, Copernicus datasets based on satellite, also in situ, and also datasets acquired by different satellites. So datasets combined with the environment, cloud-based environment, helping our users, allowing our users to process the datasets in one common environment. So maybe as a beginning, how everything has started. So everything has started thanks to Copernicus scientific program. So this is the European Union's Earth observation program. And it was established many years ago. And thanks to this program, there are different data sets gathered, non-space, in situ data sets, and also satellite data sets gathered by Earth observation satellites. The data sets which are gathered, they are distributed, they are open, available completely for free to all of the users. The data sets which are acquired every day, there are many of those data sets, so it's around 16 terabytes per day. And because there were so many data sets coming every day, European Union, European Space Agency came with the idea to create one common environment which will be a great storage of those data sets combined with cloud environment to process those data sets. So that's how CREODIAS platform was built, was established. CREODIAS platform is powered by CloudFerro company, so our company, together with different also consortium members at the beginning. So now it's around 29 petabytes of data accessible at CREODIAS platform, and also great number of different virtual machines ready to use by our users. So how CREODIAS platform looks like and what is it exactly? So first of all, this is Earth observation data repository and catalog. So here our users can access public collections of datasets, can access private collections, and also can use different data search options to find those datasets. Here also it's possible to use OGC services such as WMS, WCS, and so on. Also the datasets can be accessed through NFS or S3 protocols. So great repository of datasets. This is one side of CREODIAS. And then cloud services, infrastructure as a service. So here, getting access to the datasets, you're getting also cloud services. So you can process your datasets, you can perform different analysis on datasets, and not only on the datasets from our repository, but also on your datasets. So those are virtual networks, so connections between different elements of infrastructure. Also, you can find here different types of storage. So here we have object storage, block storage. So depending on your needs to gather the data sets and also outputs of your analysis. And also backup service, so your data won't be, and your data or your processes won't be lost. And then user tools. So starting from CREODIAS browser, when you enter the website creodias.eu, you can access our tools, which is CREODIAS Finder and CREODIAS Browser. Those are the tools helping you to search for the datasets and to download the datasets locally. Then from CREODIAS website, you can also access CREODIAS portal, actually cloud dashboard, where you can create your virtual environment. And what is more, CREODIAS also gives access to Jupyter notebooks. So different notebooks with different programming languages, such as Python, R, or Julia. So if you only wish to to perform different analysis on the datasets, you can use scripts which are open and available for free. I mean, notebooks are available for free. And also, CREODIAS is a place for third-party applications. And how the CREODIAS architecture looks like. So starting from the portal, then we have Finder, Browser, and Cloud Dashboard. You can see that here we have Earth observation data repository, which is actually divided into public collections, cache, and private collections. And then also different access services. So we perform here data search, data access, and user-generated data. From data repository to cloud services. This is all one common environment. So as here you can see, infrastructure as a service gives us compute, Earth observation data processing, block storage, object storage, virtual networking, and backup. So I would say very overall, CREODIAS architecture, but showing us that one common environment gives us a lot of flexibility, and one great data repository keeps us in one place, and we don't have to look for the data sets through many different sources. So in the terms of, for example, data processing, this is very useful. So when talking about cloud environment, we have to highlight here that we give access to our users to different virtual machines, to different flavors. So depending on your needs. Here, virtual machine flavors differs in the number of vCores, number of RAM, and also the capacity of SSD disks. So all of the virtual machines, they have already built-in access to Earth observation data repository. So when you access your virtual machine, the cloud environment, you have a folder with the data sets to all of the Copernicus program data sets. So here you can see that we start from very small numbers, small flavors, let's say, of virtual machines, and then the sizes grows. So you can see that here we have even 48 cores, 496 gigabytes of RAM, which is really great number. And also we provide here access to virtual machines with GPU, so very useful thing for Earth observation data processing. Besides, we also provide a software-ready virtual machine. So for example, ArcGIS software very popular, well-known, is already installed on our virtual machines. There are a few of them, different flavors. Besides, we have also QGIS Snap software installed on the virtual machines. What is more here, we have also dedicated servers. So in comparison to those previous virtual machines, here you can see great numbers of the virtual cores RAM and SSD disks. So if you wish to see more, please visit CREODIAS website, and you can find there detailed information about our virtual environment, virtual machines. So maybe you are already CREODIAS users, maybe not, but from this point, I would like to highlight that CREODIAS 2.0 is now being developed. So this is the new version of our CREODIAS platform. So first of all, we have created new instances of the cloud computing services, so they are already operational. So our cloud users, they have the possibility to change cloud instances and to move to WAF3 One Cloud. So here, for example, WAF3 One Cloud gives access to Kubernetes and many different flexible environments. So we have upgraded the billing system. So now it's also already operational. So this new billing system enables much greater flexibility. So here we have the native pay-as-you-go model, and our users, our customers, they got very convenient reports and also invoicing. So that's not all, because Data Explorer, which will be a kind of combination of data browser and EO browser and EO Finder, is now being developed and will be introduced to our users. So those will be really advanced tool for searching, visualization, ordering, and processing Earth observation datasets. So everything in one place. And in general, the CREODIAS 2.0 portal will be a great and improved version of the platform, combining account management with a knowledge-based communication channels, customer service support. So really useful website, really useful portal to be used by our users. So the best is yet to come, so please stay tuned. Okay, and then coming to the next point of the presentation, what are the available data collections on our CREODIAS portal? So as I have mentioned at the beginning, first of all, our data repository is full of Copernicus imagery. So all of the data sets which are gathered, which are acquired within the Copernicus scientific program. So all of the Sentinel datasets, Sentinel 1, 2, 3, 5, and 6. Also, we give access to Landsat 5, 7, and 8, and VSAT, SMOS, and MODIS datasets. Besides, we also present here access to Copernicus services and also other datasets. So such services as atmosphere, emergency, land, and marine, and also access to digital elevation model, JSON-free datasets of the altimetry satellite datasets, and also such products as to GLC, so Grand Global Classification of Sentinel-2. We also cooperate with many different satellite data providers, very high resolution imagery. So here, through our CREODIAS platform, through us, you can order data sets coming from such distributors as Airbus, Maxar, SIS, KGS, so Kazakhstan, and Chinese CG satellite. And also in the near future, Planet, and probably others. So our Earth observation data repository is growing. So it has already exceeded the number of 29 petabytes of data. So you can imagine how great is the Earth observation imagery. So you can generally find everything on CREODIAS platform. So here a few detailed slides about the datasets. Datasets coming from Sentinel-1, so radar satellite. In different products, we have the datasets which are locally held or in a orderable mode. So for example, in GRD, SAR-C band, OCN RAW, we have a full archive, RAW last 6 months, SLC, a full archive for Europe, and the last 6 months outside of Europe is orderable. Then we have also different products of Sentinel-2A, L1C, L2A, then different products of Sentinel-3. Also here you can find full archive. Then coming to the different, this slide, Sentinel-5P, Landsat, and NDSat MOS and MODIS as well. So also locally held or orderable. And then also, as I mentioned before, Copernicus services and also other data collections. So Copernicus services, which are available and accessible over S3 and NFS protocol. So they are accessible through the virtual machines, and different data sets such as digital elevation model, for example, it's offered as a different products. And then JSON-free altimetry products and S2GLC, so classification of the Sentinel-2. And then, for example, here you can see very high resolution commercial data sets. So, for example, coming from a Chinese satellite Jilin-1, which is optical, Casosat, CompSat. So you can see what's the difference, for example, between those data sets and Copernicus data sets. The difference is in spatial resolution and also revisit time. So here the resolution is even in centimeters in the panchromatic spatial resolution. And also, as I mentioned before, we cooperate with Airbus company. So, for example, the data sets coming from satellites such as Pleiades Neo, Vision 1, Spot are available, and you can order those data sets from us. So those data sets are acquired even twice a day. So you can get the data sets from the same area every day with even 50 centimeter spatial resolution. So this is really great resolution for different detailed analysis. And here I wanted to share with you interesting facts about data dissemination and use of data by our users. We have retrieved some statistics. And here, for example, you can see that CREODIAS users, CREODIAS platform users, are looking for the data sets. This is the summary of the data sets from Sentinel-1, 2, and 3 and 5P satellite. But it seems that the users are looking even for all the data sets. So, for example, here from 2017. And then we see that there is about 27% of the data sets they look for, and also from 2018, 2019, 2022. So this is very good information for us, because as we keep those data sets locally, it means that they are used by our users. So the storage used for those data sets, it's a flexible. So whenever our customers are looking for more data sets, we have those data sets within the Copernicus, within the CREODIAS platform. So those data sets are accessible immediately. So only whenever you're looking for them, you can access them and use them completely in a very, very short time. And the other statistic is showing the total transferred of the data sets from the last 3 months. Also showing here Sentinel-1, 2, 3 and 5 Sentinel satellites. So the total transfer of the datasets from the last 3 months, it was over 10 petabytes of the datasets. So we see that those datasets are really used. So as a summary of the CREODIAS platform, here just a couple of words what you need to know. So to access the platform is completely open and completely for free. You only need to be registered users to access the platform and to use, for example, user tools such as EO Finder and EO Browser. You have free and immediate access to the Copernicus datasets and services. So you look for the datasets, you get the datasets, you can order the datasets immediately. And of course, this is the downloading of the datasets locally, so to your computer is completely for free. So you can download them, download the datasets, for example, from Sentinel-1 or 2 satellite to your own computer. But also there are some paid services. So paid is cloud computing and storage service. So if you would like to use virtual machine, you have to pay for it. But here we have very flexible, let's say, approach, because for example, here you pay per usage of the virtual machine, so hourly, or you can also sign the agreement as for a fixed term, monthly, annually, or half a year. So depending also on your needs, for example, on the projects you conduct. And then on CREODIAS platform, there is available processing as a service. So here there are different available processors dedicated for Sentinel-1 and Sentinel-2 datasets. And also, but I think that's a standard, that access to very high resolution imagery, this is also something which for which our users have to pay for. So very high resolution datasets coming from commercial data providers. But to maybe to get familiar with our platform, we offered our users 100 euro free credits for the beginning. So to see how the platform works and to see what datasets are at the platform and to see how processing can be performed on virtual machines or in a cloud computing environment, you got 150 euro and you can use it for all of those services. So it's a kind of trial, and then you can decide whatever the CREODIAS platform is something that you are looking for. Then coming to the next portions of information, CREODIAS tools. So as I have mentioned already, on our CREODIAS portal, you can have access to Earth Observation Browser, Earth Observation Finder. So the so tools which are used for data search and data download. You can also create here different band combinations. You can compare here data sets gathered in a different time. So you can see what are the differences between the gathered data sets. Also, here you can have access to Cloud Dashboard, to third-party applications, and also to Jupyter Notebook. So in a minute, I will show you shortly how those tools works. But then also, as I mentioned before, on CREODIAS, there is available processing as a service. So what kind of processors are available here? So Sentinel-1 CardBS terrain corrected backscatter, also Sentinel-1 12-day interferometric coherence, Sentinel-1 cloud optimized GeoTIFF generation, Sentinel-2 Cent2Core processor. So this is the atmospheric correction processor, and also Sentinel-2 resolution enhancer. So I know that whenever we are processing the datasets, sometimes we really miss the time, for example, to conduct all of the processing. And to order those processor here on CREODIAS platform is not, it's actually time saver for us, for the people who conduct projects, because those this processing can be done on CREODIAS site, and our users will simply get access to output, so for the results of those of the processing. And here, just to show you an example of Sentinel-2 enhancer processor. Enhancer processor gives us a much better scale of Sentinel-2A datasets. So from 10-meter resolution to 2.5-meter resolution. So when we compare one imagery of 10-meter, and then when we see that 2.5-meter resolution of this imagery, we see that this is really great enhancement in the resolution. So we can perform here more detailed analysis on the imagery. Okay, so from this point, I would like to just show you very quickly Earth observation tools which are available on CREODIAS platform. So I will simply just open the platform. Okay, I'm sorry, just coming to CREODIAS portal. So here at the creodias.eu portal, you can see here in the tab Tools, EO Browser and EO Finder. So before, I mean, EO Browser is open for everyone, but EO Finder is the application you have to be registered before. So here at the when you click the register button, you can register yourself, and then you can start using the tools. So maybe I will show first login. Okay. Okay, again, I see that something went wrong. Okay, I don't know what's... Okay, somehow I'm not able to log in now. Okay, so I will just show you without logging in how to use those tools. So EO Browser. So this is the application for browsing the datasets and, for example, to visualize those datasets. So I will look for the datasets of Sentinel-2. So I click here on the configuration pane. Then I indicate the cloud coverage, so the best, the less of clouds, and then I indicate the time range. And here, of course, I'm located by my geolocation, so Warsaw, and then let's click search, and let's see what kind of data sets I can find here. So here in the tab results, I got different results of my search. So I will just show you some of it. So this one was acquired on the 1st of July. Okay, so here is Warsaw. And here in the visualization tab, I can perform different band combinations. So such as true color, which is now highlighted, optimized natural color, scene classification, for example, false color. Let's see. Okay, so in different shades of red, we have mainly the vegetation on this imagery. So the water is in dark. Then also we can see roads, let's say pavements, in dark pixels. We have here, for example, NDVI, so normalized different vegetation index. visualized here on the map. So different shades of green shows us the status of the vegetation, if the vegetation is healthy or not. But we see that it looks very, very dark green, so it's healthy. Then we can have here, sorry, moisture index. So the water content in the plants, tree crowns, for example, and many different others. And here also very nice thing which I wanted to show you is that, for example, we can download the capture of this imagery to our computer. So if we click here, download the image, so the screenshot of what we see will be downloaded, will be saved. Also here we can see my pins tab. So for example, when we see any nice imagery we would like to keep and visualize later on, we can pin a pin here to this imagery. So here, some time ago, I found some nice images showing differences in the water content in a water reservoir in Spain. So I was actually showing those images with a comparison to see how one acquired in 2021 and the other one acquired in 2022, the water was actually changed. Okay, so this is in general CREODIAS browser, data browsing and data visualization. But when we come back to CREODIAS and then when we look for the also tools and then EO Finder, we can see here more advanced data search and also the place where we can download the data sets. So here, for example, we can write down the name of a place we are looking for. We can also indicate here product at the identifier or product path. So if we know the path to Sentinel, we can here indicate the observed time. So when the satellite acquired data sets, published time, position, cloud coverage. We can order from this different processors, as I mentioned during my presentation, and so on. So for example, I will just indicate here the time, so starting from July till now, 10% of cloud coverage, and then collection, also Sentinel-2, and processing level 2A. And for example, let's move to holiday place. So for example, Italy, I can indicate here polygon. Click, and then I click search, and then I have many different results from this place. So to visualize it, I can click it here on the list. And then if I would like to download the imagery, I should simply click the download button. So the whole Sentinel-2 imagery with all of the bands, with all of the resolution of 1020 and 60 meters will be downloaded locally to my computer. So from CREODIAS Finder, so from EO Finder, you can search for the datasets and also you can download the datasets. Okay. So those were actually CREODIAS tools. And then let's come back to the presentation. Now I will give the floor to my colleague, Dr. Jan Musiał, who will give you brief overview of some analysis. And later on, my colleague Marcin Gil will present you how to set up virtual machine on CREODIAS.
Hello, everybody. Can you hear me? I hope. So today I would like to share with you some information about how to use the CREODIAS, what is the platform itself. We are talking about virtual machine, how to access them, also because a few, I guess some of you have never heard about virtual computing. So basically what you should do once you have your account, you can log into our cloud environment, such as here, for example. So this is the dashboard where you can launch the virtual machines. And here you have the my instances. So basically instances are the virtual machines, different running on this on my account. And if you would like to launch the instance, it's pretty simple. You just type here the name, let's say test. You have the source. So basically this is the operating system that you would like to select. And here you have different different choices from Linux to Windows. I prefer Linux, so I can select here Linux. Here with the flavor, this is already what Klaudia was discussing. You select the amount of resources that you require. So let's say we don't need much, just to show how it's launched. Then within the network tab, you have to select the networks that you would like to be connected to. So the first network for sure that you have to be connected is your local network. So this is the local network within our cloud environmental environment. So this is your personal subnet. And the second subnet is the EO data, where all the data are stored. So this is what you would like to select. And basically then within the security groups, you have to also select the security group, which allows you to access the machine from outside. So I mean from your local machine, because by default the access within the to the machines are only restricted to your subnet within the environmental within your virtual environment. So basically that's it. If we hit launch instance, then it would be spawned here on the list. So here we can see it's building. And what one more thing that you would have to do, it's to set up a network and floating IP. So this is the public IP, the address that will be assigned to this virtual machine that will allow you to connect from the external network. So I let's say allocate here floating IP in the while my machine is building. So here in the compute, we can see the instances, and it's already running the test machine. Here we associate floating IP. So the one that we have just created. So to explain you here what you can see, this is the name of the machine and the various IP addresses. So the EO data is the subnet, as we discussed, of the environment with the EO data, and here is your personal environment with the internal IP address and external IP address that you can use for connection. There is also possibility to access the machine from here from the environment. Here you should type, hopefully, if okay, EO console. Then the prompts wants you to reset your password. So basically here we got an access from Horizon environment to our virtual machine, And then, for example, if you would like to install some remote desktop, such as X2Go, you just go sudo apt install, I guess X2Go, hopefully client. Sorry, here you should install X2Go server, because this is what you will be using for connection. And basically that's it. The process will install the X2Go server. So here I have already a session established to such a virtual machine. This is the machine running Xubuntu virtual Xubuntu system. And first of all, what I would like to show you is this EO data repository, which basically is a folder with all the satellite data. Here you can see the name and also the name of the Copernicus services. So once you have you enter, you can see that you have all the repository, for example, of the GRD data since 2014. So there are structured month, year, month, day, and here it will take a lot of time, because here there is loads of imagery already from today. As you can see, 240 images from today. And now I would like to show you how to use our data, because the repository, how to browse this repository, because as you can see, it's pretty hard to know from the name of the folder where the particular image was taken. That's why you need to use the Finder, as we talked. So here, if we go to Finder CREODIAS EU, it looks like this. This is what already Klaudia was showing. So let's go quickly here. We go Warsaw, for example. Since July, we select the type of the data set. So we want to use the Sentinel-2 optical imagery and level 2A. So this implies that it has been already atmospherically corrected. Here the cloud cover, let's say 10%, and we go hit. And you can see that we have here only 5 images that had very low cloud cover, below 10% in July. What I can confirm, being in Warsaw, that we didn't have that many sunny days now. And here you can see the list of files. So if you click the file, here you will get the product identifier. So basically this is just a path to our folder. So if we go here and we just click it, we have the same image we have displayed, found by using the Finder. So here, and it's also nice here on the right, you can see the structure of the directory. So you have the granule, the image data, so you can see how it's structured. So exactly the same we can do here, image data. And basically this is what you would like to use to compute, for example, vegetation indices. And this is what I will show now in Python. So basically here, what is also, I forgot to mention, this is the one way to access the single, let's say, path to image. But if you would like to get all the paths, you can use here, click this, and you will get all the paths to the, so there is only 5 images to your data sets. But in case you would like to also do it more programmatically, here there is a REST query. So this is a special URL that will, if you go here, this returns the JSON response to your query, exactly the one that we have clicked here. So in case you don't want JSON, but you just want the paths, absolute paths to your data, you just go here. Instead of search JSON, you put search path, you hit enter, and here you have the paths to your query, which was done using the Sentinel, using the CREODIAS finder. So here you can see you can make pretty advanced queries when the data was observed, published, using the polygon, using your own polygon. So this is a pretty powerful tool for data discovery. And then you just copy paste this. You can just copy paste this REST query to your, for example, Python script. And this is what I have done here. So if we go to Python, you just need to install the GDAL library, which is basically the library which is used by most of the open source and even not open source software, GIS, including the cookies, for example. So in the backend, there is always a GDAL library. So here we just import the library. We put the query here from the CREODIAS finder. So basically, so basically this is how the query looks like. Some output here, and basically here also within the Python you have the URL lib library, which is built within the Python, and that's how you can easily get the absolute paths to our data sets. So if you go here, they are those paths. If you just copy paste them to here to the file browser, it will redirect you. So basically, if we want to make a batch processing, we can. We have already inserted here the paths to our images. Then, for example, let's do it like this. We will just get one image at the beginning without any loop. So then we can here make the output path for our image where we want to store it. So this will be the path where the NDVI index will be computed. So if we go, you can see that it will be in my home. And then using, as you could see here, we have to what has been returned by the query. It's not the bands, the paths to the image with bands, but to the root directory here. So you have to look deeper for the images with bands that will be used for the computation of NDVI. So this is what we are doing here for the red path. So basically here we are looking for the this is the absolute path to the red band. Here we can make the exactly the same search for the near band. Basically, we just replace the names. And then we can open the data sets. So here, it will take a time because now it has to read the data from our EO data archive. And convert also to the floating points, because further on, when you are doing the simple math, if you don't change the data type, you will get the integer instead of floats. So you will have the data NDVI only within the 0 and 1. And what you would like to get is the floats, as like here. Here we have a runtime warning, and this is correct because as we can see here, the images have no data here, so there was a division by 0, that's why it complained, but it's okay. And then basically what is going on here, we just save the data as a geotiff to our output directory. And basically that's it. As you can see here, there is a for loop, so this allows you to very easily do the batch processing to compute NDVI or whatever band math you would like to do here. So this is how you can do this in Python. And then we quit and we have the same using the bash. So this is also Linux. How to do this in bash. This is a bit easier. Exactly the same query. We specify a query, we specified output directory. Then we look for the paths. So basically here, it's very important that you don't use the find comment, the system find within the EO data like this, because then you are browsing like hundred thousands of files or even more. So this command won't work. So that's why you have to always use the CREODIAS finder, like I did here, and to generate your absolute paths. So as you can see here now, if we go echo, here we have the list of the files, the same as we got in previously in Python. So then let's say for one file exactly, again we can make it like this. Again, this is the root dir. This is not the dir, the absolute path to our bands. This is the absolute path to the root dir where the paths are stored. So we need to look for them. So basically, I will just copy paste this. And then we make a path for our output product. So if we go echo so here you can see it will be stored in our home. So then it's just the GDAL calc. This is the simple utility within Bash that allows you to do the cloud band math. And to be honest, it's the fastest one. It will complain again because there is a division by 0, but still this is okay. And after a while, it will compute the product. And maybe not to waste time, I will show you how to do it. Oh, it's already done. how to do it in Snap. So in Snap, you can also open the product, but this time you need to open the XML file. With the Sentinel-2 image. It takes some time to read, because here the Snap is not reading one band, but all the bands and all the metadata. As we can see here, the bands are there, and we can use a very simple graph, let's say, band math. Again, it will take some time because Snap is not the fastest software on earth. And here you can see the equation, so it's pretty simple. You just write it again to our home, and basically you hit run. And in the end, you can see here that the product will be computed either in Python, GDAL, or Snap. So this is how you can access and do the batch processing to compute, let's say, NDVI, but also whatever other indices you would like to do. The thing is that within Snap, it's way more time consuming. As I said, the Snap is not the fastest software on earth. So from my experience, I can advise you to use the GDAL, like GDAL Calc, for example. Here, it's way faster, and it does not have any issues. It's already a stable software. Yes, so basically, I think I'm done with my presentation. Now I will hand over to my colleague Marcin. Thank you.
Hi. I will show you some tips and tricks regarding the creation and usage of virtual machines, virtual resources. This is based on our experience with customers who use our resources for several years already. And so first I will share the screen and switch to okay. So first of all, how you log in. You already saw how to log into to your resources in CREODIAS. Basically, we have two clouds at the moment. We have so-called CF2, so this is our current cloud, and we have also the new one called WAF31. So this is these are two addresses, different addresses, but I will show you how to use the first cloud, and the second cloud is already ready. So if you want to use it, you can also apply for access to this new cloud. So you can log in two different ways. You can use either OpenID or you can use Keystone credentials. So OpenID is the same as you are using when you use CREODIAS platform, that is CREODIAS web customer portal. So I will also show you how it looks like customer. So this is the customer portal. So you can log in here, and then you can, for instance, I log in as Maria Green. And when I am here, I can see my account, and I can also access my cloud environment from this portal. So this is one way. And then I'm using OpenID Connect. Other choices are for other users, but usually you do it like this. And when I connect, I can have access to my virtual resources in so-called OpenStack. So this web that you see now is built on software called OpenStack, and this is quite sophisticated tool. So there are some pitfalls that you can encounter, and this is why I want to show you some tips about it. So now I will log out from here, and I will show you the second way of logging in. The second way is using Keystone credentials. If you use Keystone credentials, you have to remember not only your username and password, but also your domain. So, for instance, if I want to use my domain of another user, test user, and then I have to remember the number of my account, and then I will use I will choose the user. Just a moment. I will open it's called Ion Tichy. So I put this name and the password, and now when I connect directly to this dashboard, which is called Horizon. This is the OpenStack name of this dashboard. And one difficulty that our users find is the choice of the projects, because by default, when you register to CREODIAS, you get access to two projects, and this choice of this project is at the top here. So by default, you have access to two projects. One is called with error, and another called is without error. This is historically the choice when one of the projects did not have access to EO data, but now both have access to EO data, so it doesn't matter in which one you create your resources. And in the future, in next cloud, in WAF 3.1, you will just have one project, but at this moment you have two projects by default. So you can choose any of them to create your resources. And for instance, here you can see that in this project, I have no instances and no resources, in fact, only security groups. And this is also important to see this page, because it shows you how many resources you can create. So for instance, you can create 41 instances. You can use maximum 161 vCPUs and RAM. All this is called quota, and this can be set by us, by support or our administration. So if you need more resources, then you just should apply to our department, support department, and then we can set the new quota for you. Another difficulty is the keepers. So by default, you can see that, for instance, I have here keepers. One is with my name, and one is another one created. So I will show you what the problem is when I create one instance. So let's try now creating the new instance. So I will call it test web 03. And next is choosing the sorry, in this project I can see no just a moment, no images. So I will switch to because this was created in some other way, so I will switch to another project, this one project. And now I'll create an instance here in this project. And when I choose, I have to set the configuration to create resources. And now when I choose the source tab, I can see that, first of all, I have choice of various images. And here, important thing is that our users sometimes do not properly understand, because it's quite a sophisticated feature. It's that you can use, you can choose either image or instance snapshot or volume snapshot. So usually you create instance with just choosing the image. But if you create a snapshot of your machine, the snapshot also creates a local image in your project, so you can use it as well. And you can also create volumes which are bootable. So these are the choices that you can do. There are quite many possibilities, so it's not enough it's not enough time to talk about all of them. So I will not talk about creating from snapshot, for instance. But if you need some more information, you can always choose, look for additional documentation on our page. This is on CREODIAS. If you click on Docs, you can have access in frequently asked questions. You can see various articles. So if I click all, then we will see the all articles, so you can see all of them, and you can also choose some concrete, some special information, like for instance here Horizon. These are about creation of resources and maintenance of resources in Horizon OpenStack. So come back to creation of the machine. And then this is also interesting item, because you can create virtual machine with a flavor that will be on next tab. Just this setup that is already here in flavors. So maybe let's go to these flavors, and if you see, if I, for instance, choose the EO1 medium, I will have 2 vCPUs, 4 gigabytes of RAM, and total disk 16 gigabytes. But if I want this special media, special flavor, but with bigger system disk, then I can choose, in this source, I can choose create new volume. And as you can see, it allows me to choose the size of the volume. So let's say that I want to have 30 gigabytes of disk. And I can also choose whether this volume will be deleted or not when the machine is deleted by me later. So if if I leave that the volume should not be deleted when I delete the machine, so then I will choose no. And now let's choose the image. Let's say this will be Ubuntu, and go to flavors, and let's choose this medium, as I said before. So as you see here, it shows 16 gigabytes, but come back to source, I will have 30 gigabytes of disk. So this is another option that I can use. Sometimes it's convenient, because if you install applications on the disk that are really disk consuming, then you can you will need a bigger system disk, because this is for system disk. Of course, you can later add volumes to your virtual machine, but then it will be just additional volume. Okay, so let's go to the next step. This is networks. And sometimes our users forget to add, for instance, your data. So if I click on like this, just private network, then I will have no access to your data. And this can be fixed later. I will show you in next step. So at this moment, let's not add your data. Network ports, this tab is not important. You do not need to do anything here. And now security group. And this is also a quite common mistake that our users forget about adding this, allow ping SSH RDP. And this is necessary to access the virtual machine from, for instance, from your terminal. So let's also do not add this. So we will see how this problem later occurs. And now keepers. I said that this is also source of mistakes or some problems. Here you can see that I already have two keepers, one with my name and one with the name of the user, Tichy01. I can create the keeper here in OpenStack. I can also import the key when I create it in outside of OpenStack, for instance, in the terminal. So there are several ways of doing this. And common mistake is that let's create the keeper here. I will call it, for instance, Tichy02, and click on create. Sometimes it does not respond for the first time. So, and here is the my private key generated. Of course, please remember, this is also important, not to show your private key to anybody, because this gives you access to your virtual machine. And now, if I want to use this private key, I need to copy it to clipboard and go to my terminal and go to, I'm on Mac, so I opened the terminal, and normally I need to go to .ssh catalog, and this is what's inside. So I already have some private keys here and also one public key. And I will use VI as my editor, and I will open the new file, call it Tichy02, and PRV will, so I will paste the key from OpenStack to my new file. So I open the file, and now I paste. Oh, sorry, I forgot to. Once again, sorry. So I need to copy it once again to clipboard, and now. Okay, so now I copied the key to the file. I save the file, and as you can see, I have two keys. One is previously created, Tichy01, and the second one is Tichy02. And maybe you can notice that the writes to the first key are different from the second key, and this will be so if you just copy the key to the file, by default you will have the writes that will not allow you to log into your virtual machine. So I will show you in a moment how this will be visible. And so when I created the key pair, and copied it to the file, I can click done. And now, as you can see, the key is already attached to the machine. So one common mistake is not attaching the key pair at all. And second, you will see the problem in just a moment. So having this, I can click on Launch Instance. And now the instance is being created. It's called Test Web 02. As you can see, there's block device mapping. This means that there is additional system disk created, which will be bigger than default shown on the flavor. So it takes a moment. Normally, if you do not create additional disk, the creation is a little bit quicker. And now the virtual machine is being spawned. Okay, so now this shows that the machine is running. And as you can see, it just have one address. It's different from, for instance, here we have also floating IP. And it's different from this machine, which has not only private network, but also floating IP and EO data. So it means we did not attach EO data to the machine. We can fix that by attaching the interface from this menu on the right. So when I click Attach Interface, I can select Network and click on EO Data. And so now also EO data will be accessible from inside the virtual machine. So it takes a moment. And as you can see now, we have two networks. One is private network and one is EO data. Private network is necessary to have access to external world so that you can connect to the machine from the internet. And I will go now to the network to show you how the topology looks. So this is the topology of the network. And you can see that in this, we have external 2, external 3, and external. This is also creates some problems that customers are asking why these free externals. This is because we have limited number of IP addresses, and they are from different pools of addresses. So this is why we had to create additional networks when the number of our users grew, and we had to buy additional floating IP, so additional addresses. So in this project, the router is connected to external. So this means that floating IPs will be used from this external. And as you can see, this test web 2 is connected to private network and to your data. But when you go to compute once again to instances, you will see that there is no floating IP attached. So I need to attach floating IP. And now there is also a problem that our customers encounter. First of all, now I can use this floating IP because I have it already attached to my domain. But if this place is empty, I can generate it by clicking on plus. But when I click on plus, then I have choice of various externals. So I can generate floating IP from various externals. And if I create floating IP from external free, for instance, let's do this for the test. So this is from, you can see that these addresses are from different pools of addresses. And this one is from external free. So let's try to attach it, associate. As you can see, and you can see that we had error. Unfortunately, these errors are difficult to understand, but the error is that we were not able to associate this IP address because this was from different network. So this is the problem which can be fixed by attaching the floating IP from not from external free, but from external one. And you can see it from here that, for instance, 185 and 1.178 is from is proper. So let's add this one. And also another problem that our users encounter is if they attach the IP floating IP to your data network. So this is your data 10.11.1.167 is the address of your data. So if I choose this one, I will have error again. So I need to add it to this network. So this will be correct. Okay, so when I have this attached, I can copy this address, copy it to go to terminal, and SSH -e means that I attach the key, and let's try with this key, the new created key, here user, and the floating IP. And when I click enter, nothing happens. and we will wait and nothing happens. And this means that there's something wrong. Let's go again and first of all, check the security groups. And as you can see, we did not attach the allow ping SSH RDP. So we need to fix that by adding this, save. Wait until the security group is attached. Okay, we have confirmation. Now go to this, try to once again. And as you can see, there is this means that this address has already been used, but I can fix that by just a moment. I'm not sure now, but I think I have to fix. Well, another problem is that I didn't change the mode of this key, so I need to change mode 600 and like this. And now, as you can see, I fixed that. And now try to SSH again. And this did not work because I need to fix because this address has already been used. I'm sorry, but I don't have this command how to fix that here on Mac, and I don't remember it. So we can fix that by attaching the new address, which was not used before. So once again, associate, and I will add another key also from external one. So I'll create a new one. Okay, and I will attach it. And copy it. Paste it to the command. And now it allows me to log in. So I'm already logged in, and I can check whether I see your data. Yes, I have access. Okay, so this was workaround, which I used. I see that time has our webinar should be finished now. There is, in fact, I should use another command to clear this error that I had by SSH to the machine. So I just used workaround. If you need information how to do it, please send us request to our customer support, and I will answer this later after the webinar. Okay, so maybe you have some questions. It's already nearly finished our webinar, but maybe you will have some questions. So please ask. Please ask now.
Okay. Thank you very much, Jan and Martin, for your part. So maybe before questions, we would like to encourage you to visit our website, cloudferro.com, webinars, where you can find the list of our upcoming webinars and also videos from our past webinars. You can see displayed our email addresses. So if you have any question, please write us an email and we will then answer your questions. Okay, so thank you very much for attending our Introduction to CREODIAS webinar. We hope that you enjoyed, and hopefully I will meet again during our next CREODIAS webinars. Thank you very much for attending. Thank you. Bye-bye.
Thank you. Bye-bye.